radiation, climate, and climate change. Our planet constantly absorbs radiation coming from the sun in the form of electromagnetic waves. If the Earth did nothing but absorb radiation from the sun, it would get hotter and hotter until the surface temperature became high enough to melt rock. Happily, there are two reasons why this does not happen. One is that the clouds, snow, ice, and sand reflect about 31% of the incoming sunlight back into space. The fraction of incoming sunlight that a planet reflects is called its albedo, from the Latin for whiteness. Thus, the Earth's albedo is about 0.31. Thus, only 69% of the incoming solar energy is absorbed by the Earth. So as you can see in this picture, sunlight, in number 1, sunlight arrives at the Earth. Part of it arrives at the Earth and part of it is reflected by the clouds. And number 2, we know that 31% of sunlight is reflected by clouds and the surface. So 31% of the sunlight would be reflected. And as we can see in the 3, sunlight that is not reflected is absorbed by surface, heating it. So 69% of the incoming solar energy is absorbed by the Earth. So now let's see what happened in the continuation. A second reason is that the Earth also emits radiation into space because of its temperature, in accordance with the laws that describe heated dense objects. So as it's shown in number 4, and the red waves, heated surface emits infrared radiation. And in number 5, we can see that some infrared radiation is trapped by atmosphere, heating both atmosphere and surface. And 6, remaining infrared radiation leaks into space. So let's see what will happen that may cause problems. The Earth's average surface temperature is nearly constant, which means that on the whole it is neither gaining nor losing energy, a state of which is called state of thermal equilibrium. Thus, the rate at which the Earth emits energy into space must equal the rate at which it absorbs energy from the sun. The presence of an atmosphere on our planet has a significant effect on this equilibrium. Given the amount of energy reaching us from the sun each second, as well as the Earth's albedo, we can calculate the amount of solar energy that the Earth should absorb each second. Since this must equal the amount of electromagnetic energy that the Earth emits each second, which in turn depends on the Earth's average surface temperature, we can calculate what the Earth's average surface temperature should be. The result is very chilly, 254 Kelvin or minus 19 degrees Celsius or minus 2 degrees Fahrenheit. So cold that oceans and lakes around the world should be frozen over. But in reality, we know that we see that the lakes and oceans are not frozen, and the average temperature is much higher than minus 19 degrees centigrade. And let's see, why is that? Why is the Earth warmer than we would expect? The average surface temperature of the Earth is 287 Kelvin or 14 degrees centigrade. Most of the radiation that our planet emits into space is infrared radiation. And most of the radiation emitted by the sun, which has a surface temperature of 5,800 Kelvin, is in the visible part of the spectrum. to which our atmosphere is transparent? The answer is hidden in certain gases in the atmosphere called greenhouse gases, which is causing a phenomenon called greenhouse effect. Our atmosphere prevents some of the radiation emitted by the Earth's surface from escaping into space because of the existence of these gases, which water vapor and CO2 are some of them. Molecules of carbon dioxide, which is the atmosphere's fourth most abundant constituent after nitrogen, oxygen, and argon, and water vapor absorb some of the infrared radiation coming upward from the surface. They then re-radiate the absorbed energy, but some of the re-radiated energy is directed back down toward the surface instead of escaping into space. In order to maintain thermal equilibrium, the Earth's surface must compensate for this by increasing its temperature T, and hence its total rate of radiating energy, which is proportional to T to the power 4. This phenomenon, called the greenhouse effect, makes our planet's surface temperature about 33 degrees centigrade higher than it would be if there were no atmospheric CO2. If CO2 were absent, the Earth's average surface temperature would be below the freezing point of water, and life as we know it would be impossible.